All right, ladies and gentlemen, Bio 30, welcome to the world of pedigrees. So you have filled in your chart, that chart that took a lot of time. You filled it in and you probably looked at it and thought, what the heck? What is this? So let's talk about what are pedigrees. All right, so I'm going to talk about the basics of pedigrees in this first video. And then in my second video, I'm going to show you guys how to solve pedigrees. So what are pedigrees? Well, pedigrees are essentially the diagram that shows us how traits are passed on in families. There are key pieces to it, legends essentially, that we have to have in order to understand how to read it. So you'll see that anytime I have a circle, it means female, and anytime I have a square, it means male. So this just represents people within the pedigree. Depending upon what kind of pedigree it is, you may see things like inbreeding between relatives, which shows a double line. Normally, if they are married, there will be just one line, or if they've had children together, there'll be just one line between them. Inbreeding means double. You will also notice that there is a indication if someone has died, if there are fraternal or identical twins, or if their sex is unknown. So perhaps the baby died young, nobody knows if it was a boy or girl or something like that. You can show it with a diamond. So again, we have a line between the circle and the square that indicates some sort of mating. And then from that, we bring it down to indicate the offspring. We always read a pedigree left to right as if we're reading a book. So the oldest individual will be on the left side and always on the left side. And then it moves across the right, going younger in age. Affected individuals, so someone who has a disease, will be shaded in. Now, that could mean they have a dominant disease or a recessive disease, but shaded in just means they have a disease. You won't see this very often, but heterozygous individuals are half shaded in. And I'll show you what that looks like as we move forward. So this is just a little bit more about pedigrees. So again, the circle represents female. So you're going to want to write female in here. And you're going to want to write male here. Oops, not sure why that disappeared. Oh, because I'm using the magic pen. Sorry. I gotta change that. So female and male. I just want to change this. Okay. And I don't know if that's going to work. And the shaded represents family with the disease or with some sort of trait. So it says here, shaded represents the expression of the trait for dimples. Shapes that are not shaded represent family members with no dimples. In this example, the blank has dimples. So it's saying if it is shapes that are not shaded, represent that no dimples. So in this case, the female has dimples because she is shaded in. That's what this one is saying. So again, female. I apologize. I'm going to have to figure out how to change my pen. It's not letting me. And I can't write. That says female, if you didn't know. That's really great, hey? All right, a horizontal line is used to connect, we're going to say mates or someone who is married or someone who's had offspring together, okay? So that's what this line here means. This line means parents down to children. So the lines that connect parents and children, the oldest children are placed on the left. Okay, so anyone on the left side of this is going to be the oldest. So for example, here to here to here. Okay, so oldest daughter, middle daughter, youngest. Okay, and the youngest is on the right. Again, I apologize for my disappearing pen. I will fix this after. In this example, there are 3 children, 2 females and a male. The male child has no dimples because he is not shaded in. Okay, so this is kind of how you read a pedigree. This is how a pedigree starts to look. Oh, just trying to change my pen. There it is. I don't want the magic pen. There we go. Okay, let's try this again. So here is an example of what a pedigree actually looks like. This is the Lee family, and we have dimples and no dimples. So you can see that shading means that the people have dimples, and no shading means no dimples. So when you are reading a pedigree, it is important to understand what you are reading and how to read it. So we label generations. So each one of these sets is a generation. So this would be generation 1. Sorry, guys. This would be generation 2. And this is going to be generation 3. Can you tell I'm using my mouse to do this? That was an accident. I apologize. So that's generation 1, 2, and 3. Okay. Now you can then label each family members with numbers. So this would be a 1 and this would be a 2. Now, when you go to the next generation, you start over again. So 1, 2, 3, 4, 5, 6, and 7. Okay, so then you would label the next one 1, 2, 3, 4, 5, 6. So now that I've labeled my generations and in each individual, I can now read this because it says how many children did 1, 1, and 1, 2 have. What 1, 1 means is generation 1, person 1, and generation 1, person 2. So it asks how many people did they have as children. So you follow down and you look for the lines that are attached to this line here. So I can see that they had a daughter. I do not count this son because it does not have a line down. This is her partner or who she married. So this is the daughter. So 1, 2, 3, 4. So generation 1, person 1 and 2 had 4 children. How many children, what was the sex of each of their children? They had a daughter, circle, square, circle. So they had female, they had 3 of them, and males, they had 1. And again, the oldest child, it starts on the left side reading right. So left would be the oldest child is a female. Okay, so that's kind of the simpler way of reading these. So looking back at the Lee family, we're just going with this. It says, assuming that having dimples is a recessive trait. Okay, recessive. So dimples is a lowercase d. And no dimples is dominant. So I'm going to give that a large and uppercase D there. Write the genotypes for all the individuals on the pedigree. So what I'm going to go through is I'm going to try and label these my best I can. Anytime I see a person who is affected, meaning they're shaded in, having dimples is recessive. So anytime I see someone who's shaded in, I know they are going to be 2 lowercase d's for lowercase for dimples because this is the recessive trait. So these ones are kind of the easy ones to do right off the bat when you're looking at a pedigree because you know what their actual genotype is because a recessive individual can only have 2 recessive alleles. So it makes my life a little easier when I go through and I can just label these right away. Once I'm done labeling these, I have to start making some decisions about the ones that are not labeled. Oh, that's a D. That's D. Everyone else has a dominant gene. So I 100% know that any of these non-shaded individuals have to have an uppercase D as part of their genome. So I'm going to just go through and I'm going to quickly write those in because they have to have a dominant gene. I have to be careful though because I have to make the decision about are they heterozygous or are they homozygous dominant. So looking at this person up here, at this point in time, I don't know what they look like. I don't know what their genotype looks like, so I'm going to give it a little blank. Why? Because I don't have any information above. There's no information telling me what this person has for parents, so I just know that they are big D with a blank. Now, I'm going to change that here in a bit, and I'll explain why. So now I'm going through, and I'm going to look here, and I'm going to say, okay, this is big D, and I need to know what its second allele is. Let's look at their children. Both their children had the recessive type of, so they both have dimples. Mom can only pass on one of these alleles. So that means that dad had to also pass on a lowercase d. So dad is heterozygous. We know that this daughter received the uppercase D from mom. So she has to receive one from dad. So she's going to also be heterozygous. Same with their other daughter is going to be heterozygous. Now, looking at their children, this daughter here got the uppercase D from mom, so she's going to get the lowercase d from dad. So she's also heterozygous. So I said I was going to come back to this individual and not leave them blank. I originally left them blank because I said, oh, I have no information above to help me. But I do have information below that will give me an idea of what mom's genotype is. Mom and dad had 4 children. Out of the 4 children, 2 of them have dimples. And because dimples are recessive and dad can only donate one of his alleles, that means mom for sure had to have a small allele or a recessive allele in order for that to happen. So I can actually fill in her genotype. So you can see it better there, a little bit nicer, okay? So when we do this, we've once have the genotypes written down, we can now go and we can have some educated guesses about what we think individuals moving forward would look like. So what is the chances that the next child of individuals 2, so 2, 1, and 2, 2 will have dimples? So again, this is just a simple Punnett square. I know that if I create a Punnett square, I can put the alleles above. Okay, there we go. And I can just quickly do my Punnett square. And what I'm seeing here is that the chances of them having dimples is going to be 50%. So 50% right here. Now, again, you may look and say, well, but both their children already have dimples. How does that work out that it should be 50%, but both their children have dimples? You have to remember the rule of probability is that this resets every time. So there was a 50% chance this child would have it, and they did. There's a 50% chance this child would have it, and it did. So if they had another child over here, I'm just going to add, let's say they had a daughter. This daughter has a 50% chance of having dimples or no dimples. It resets every single time. All right, so again, it's asking this question here. What are the chances that these two individuals will have a boy with dimples? Okay, well, what is the chance that the next child will be a boy with dimples? Well, we know having dimples is 100% a chance because they only have recessive alleles. So what comes into play is dimples is 100%. Okay, so we have dimples at 100%. That's a 1. Okay, but boy is 50% because they're either having a boy or a girl. So it kind of comes down to this is your answer. Because no matter what, they're going to have dimples. It's just whether or not they have a boy or not. Okay, the boy is the chance here, the 50% chance. Dimples is 100% for sure because they both have the recessive allele. I'm going to go through on another video and teach you guys now how to utilize reading these and using the chart that we built in your notes and how to solve pedigrees. So watch for the next video and I will talk to you soon.